My name is Praveen and I welcome you all to yet another edition of Java Fun Programming Tutorials. Today we're going to talk about GraphQL. This is a new technology happening in the Java world right now. So we're going to talk about today what is the basic concepts of GraphQL, how to implement GraphQL in Java. So those of you who don't know what is GraphQL, GraphQL is really a specification released by Facebook. So this is one of the strategy to implement the REST endpoints. Uh, so it is kind of a competing technology for the REST. There are different philosophies by which you can implement the REST endpoints. So today we see what is GraphQL, what are the building blocks of GraphQL, and what are the strategies or the development philosophies available there to implement the GraphQL endpoints in Java. Okay, so if you're coming to my channel for the first time, uh, please subscribe. We generally bring videos about the different happening technologies in the Java world, and we created the in-depth tutorial for each and every technical concepts. So today also, if you like it, please subscribe and like to my tutorial. Thank you. So what exactly is GraphQL? So GraphQL is nothing but a query language for your APIs. So let's see what exactly that means. So in a REST world, whenever you are creating a new API, basically what you do is you have server side, basically they create an API and they basically tell the client side, this is my contract. So that API may be a get query or a post query, and they give certain response back as part of that REST API. Once that contract has been fixed, client side has generally no control over what kind of a data it is coming from the server side. They are just at the receiving end. They cannot modify the data. They cannot basically restrict the data which has been coming to their system. So that those are the problems which GraphQL tries to solve. So basically, GraphQL provides the complete description, understandable description of your REST endpoint. So if you see in the REST world, there are technologies available like Swagger, which basically gives you, or the Spring REST docs, which basically gives you the uh, specification or the description of your APIs, but they are just at the documentation level. It basically, with that technology, you cannot restrict or basically rename the data which has been coming to your system. So it makes very harder for the clients to work independently. They are always dependent on the server side for the data and for the specification of their APIs. So GraphQL basically tries to simplify and fix some of those problems which is there. What are the advantages of GraphQL over REST? So as I said, the client basically controls the response of your REST endpoint. Client basically tell the server out of that response how many attributes he basically want. So suppose you are returning certain object as part of your response, and that object has like 10 properties. Now one client, suppose you have multiple screens on it and that API is getting called at the multiple places, server side, at the server side, you're not necessarily going to create two different versions of that particular API. So what will happen is, even though other screen doesn't use all those attributes, we are still sending that data over the wire to them. So GraphQL basically tells the server out of those 10 attributes how many attributes they want. So their client is basically controlling the response. So there will be no under or the overfetching of the data. You are basically reducing the amount of data that you are sending out from the server to the client side. Then the one major difference between the REST and the GraphQL is GraphQL only works with a single endpoint. In the REST world, for each and every specialized thing, we create an endpoint and then we define those as part of our controllers, Spring MVC or Jersey, all those kind of things. But in GraphQL, there is a servlet, and that servlet defines a single endpoint, and all the functionalities that we want to expose get exposed via a single endpoint. So basically what is happening is that endpoint is basically accepting something called as a a query, GraphQL query, and using that query, then the delegation of your responsibilities will happen to fetch the data from the server side. Once we go to an example, that will be more clearer, and there will be decoupling of the business logic. So basically, suppose there are two entities on the server side and you want to combine the data of both those entities and send it back as a response to the client side. What will happen is, basically, if those are the database entities, you may have a join in place uh, at the model or the entity level itself, or you may need to make two different calls, but that call's logic will again embedded within the single method to fetch the other entity and then basically massage that data and sending it out. So GraphQL basically allows you to decouple those logic. Again, we'll go to the example and that will be more clearer. uh, so we'll see what are the building blocks of the GraphQL. So every GraphQL endpoint comes with something called a schema. So the way you have a database schema, GraphQL, similarly you create your own GraphQL schema. In the GraphQL schema, there are four different types of building blocks. Some first is called as types. Types is nothing but the objects that you want to send it as a response. So the way you have a symbol pojos in case of Java, you create something similar to that in terms of type, and that types basically have values defined, or the data types defined for those, like a string, integer, boolean, all those kind of things. So it is called as a scalar value in case of GraphQL. And then once that is defined, for any functionality or the data that you want to fetch, you will create something called as a query. If you want to update anything, you create something called as a mutation. Subscription is nothing but if you want a push mechanism kind of a thing, wherein if any particular entity is getting updated, you want to receive push notifications, then that is also possible in case of GraphQL, and we'll see an example of that today. That is called a subscription, and we'll see the how those are defined. So this is something called as type. So in our today's example, we're going to create two different types. First is actor and another is film. So we'll create an actor object, and actor basically acts in a film. So that's how they are joined together. And one actor can work on a multiple films as well. For simplicity's sake, basically for today's example, we'll see that one actor is working in a single film. And what are the attributes of those actor entities? So actor can have an actor ID, first name, last name, the date of birth of an actor, address, and the film she is worked on. The film basically has a name, year, the year in which it is launched, and who are the actors basically worked on it. So if you want to model it on a Java side, we'll see how to model it. Now let's go on to, if you want, okay, so the next thing is a query, right? So if you want to query it, you define something like this. So you say my query method name is basically get actor by name. So I'll give a name, actor name to the backend, and they will receive me they will give back me the entire actor object fetched from a database. So if I want to implement that particular thing, how should we implement it? We'll see that in detail. Mutation is nothing but updation of entity or a data on the server side. So I'll say if I want to update the name of an actor. So this is kind of a method that we'll be exposing. And subscription, basically whenever his actor is getting updated, I want to receive push notifications. So the type in this case is subscription. So there are two development philosophies, and today we're going to talk about the schema first approach. And there is another YouTube video created in the same series. You can go and find it out in the description box, which is called as code first approach. So in schema first approach, what we're going to do is we first define the GraphQL schema. That schema is shared between the client and the server, and then client basically using that schema makes the queries, mutation or subscription, and it basically restricts the amount of data it want to fetch from the server side. So in this lecture we're going to talk about the schema first approach, and the next video is created to implement the same thing using the code first approach. In the code first approach, you're not defining the schema, but the schema is getting generated at the runtime. So both of those approaches has their pros and cons. So today we'll see how we can implement those. Okay, so I'll go back to my IntelliJ IDEA. and I've created a simple Maven project, and currently it doesn't have anything, it's empty. So to start working with it, what we're going to do is, first we'll add certain dependencies that we need to work with. So firstly we need a database to work with, so I'll just add the in-memory database, the HSQLDB. Okay, let me add HSQLDB. And we'll be going to use the in-memory version of the HSQLDB. You can, if you want, you can use the file-based version as well. Next thing we want to do is, since we have a database, we need a Spring-boot-starter-data JPA to work with the database. Next thing we will be having is Spring-boot-starter web. We will get Lombok. Then we need certain GraphQL dependencies. So here I'm adding mainly 3 different dependencies for GraphQL. So first is GraphQL Spring Boot Starter, then the GraphQL Java tools, which basically gives you an UI interface to test your GraphQL functionalities or the queries or the mutation that you are exposed. And basically another thing is in graphical Spring Boot Starter is a UI interface for working with the GraphQL. So let's see, after this one what we're gonna do is, let me create a package, and we're going to create the 2 different entities that we're going to work with. So one is actor and another is films. So I say com java fun model. So that will be my first package. Next package would be the repositories that we want to work with, the Spring Data repositories. Java fun repository. Next thing we want, we will be creating a service classes. So these classes are basically the one who will be holding the main business logic that we're going to implement it today. So first I will create an actor. Let me create the package first. Okay, and our bootstrap class to start our service. Okay, since it is a re-import it so that it will fix my class path. It is not giving me the certain web dependencies which is there in the POM. So let's see now it's much better. Okay, so spring application dot run bootstrap dot class, and I give the arguments. Okay, much better. Now this is our main class. Now we move on to the different things that we wanted to work on. So first, as I said, we'll be adding two entities. First is actor and another is a film. Okay, and let me add certain properties in both of those. So this will be our JPA entity, and it will be connecting, it will be mapped to the table called as actor only. Second thing is film, map to film. Let me add a properties file. I'll be putting the connection properties for my HSQL in-memory database. So I did DDL auto to create. So whatever properties I'll be putting into my entity class, it will create a table out of those automatically whenever my service restarts. Okay, so now let's see what all the things that we basically wanted to add into our actor entity. So first thing I want is actor ID. I say actor ID. Second thing I want is actor first name. Then the last name of the actor. Then we need a date of birth of the actor. Then I need an address of an actor. And since we want to show the relationship between these two entities, so what I will say is actor basically works in a film, so I'll join those using the film ID. So we need to create a similar property on the film entity as well. So basically first I will do, I'll create the constructor. So since actor ID will be auto generated, so I'll not use that. Okay, and then I need a getter and setter for all of those. And since it is a JPA entity, I'll be creating a default interface as well, a default constructor as well. Okay, so we are set. Just map it with the column now. Using the strategy auto. Okay, much better. Now this will be our first entity that we're gonna work with. After this one, we gonna create another entity which is called as film. So let's see how to what all properties that we need to add into the film entity. Okay, so let me go to the film entity. It will be auto generated anyways. Then I need a default constructor. I need getter setter. Okay, we are set. Both the entities has been created for us. Okay, after the entities, we're gonna create two repositories to fetch those entities from the database. So first will be my actor repository. And this will be an interface. Second will be film repository. Okay, let it extends JPA repository film, primary key is integer. Okay, similarly for an actor repository. Okay, our repositories are in place. Now we need to mark them a Spring service to be usable in the other business logic. Okay, so this is in place. Our model in place is repositories are in place. So let's now create a service classes. So first I'll create a actor service, and then I'll create a film service. Okay, again this will be a Spring service. Okay, now the next thing that we need to do is, for any GraphQL application, you need to first create a schema, or you need to auto-generate it. So we will go ahead and see how the schema can be created. For today's tutorial, or for any GraphQL application, basically you need to put your schema file into the source main resources folders inside the directory called as GraphQL. So this is my directory. Inside that I need to create my schema file. So your file name can be anything, but its extension has to be GraphQLs. So basically, whatever schema that you're creating, it has to end with the extension called as GraphQLs. So I'll give the name as schema only. So this becomes my GraphQL schema file. So if you have noticed, its icon has been changed. That is because I've added a GraphQL plugin into my IntelliJ IDEA. If you can search into the plugin section of the IDEA, you can see there is a GraphQL plugin is available, so you can add it there. It will be much useful while doing the development of a GraphQL schema file. So as we have seen into the presentation that I shown, GraphQL basically has certain built-in blocks. There are types, there are queries, mutations, subscriptions. So type, as I told you, it is the object which you're going to use for the response of your endpoints. So basically, you need to start defining the types. So my type, first type would be an actor, and second type would be a film. Okay, and we need to create a query as well. Okay, so let's see. So let's start defining the GraphQL type actor. So basically, it should contain all the attributes that you're putting into your model. And you need to basically, the syntax to define those will be a little bit different from Java. So first what we can do is we can copy whatever we have defined in the first place, so and then we'll change it. So this is for actor, and this is for film. So let me copy it first. Okay, the non-necessary things will remove it first. So I'll remove all those JPA entities out. Similarly, I'll do it from the films as well. Okay, now these things are left, so we don't need these private classifiers, so we'll get rid of those. Now these are the attributes which is there already in place into your GraphQL, into your Java models. Now you need to define it in the GraphQL syntax. The way to define those things is you need to give the name first and then its data type. Okay, so actor ID is basically an integer, but actor ID is basically a primary key for your entity. So in case of GraphQL, it has a special data type called as ID, and ID basically corresponds to a identity of your entity. So I'll call it as an ID, and the exclamation mark suggests that it will be a non-null, it will be a mandatory field. Now first name is string, and you have a string data type in GraphQL, so I'll put it after colon. So again, the last name, same thing for last name, and you need to put a comma after whatever now there is no data type called as date into GraphQL. So what we can do is we can map the date to a string, so it will be auto translated to a string format of a date. Okay, and then film ID is basically an integer, so there is a data type called as int in GraphQL to determine the integer data type. Now let's see how it works. First we'll change it out for these things as well. Then the name is string, and date will make it string only. Okay, now your types are in place, and you need to create a query now. Now query is basically, think of it as some kind of a REST endpoint. You need to basically give a name for a query, and what will be the response type of that query. You need to specify into GraphQL schema file. So my first query would be, I want to get all the actors which is there into my database. So I'll say get all actors, and since this will be more than one, um, I can do is I can get say that my data type would be an array of actors. Okay, so this will be my first query. Now I need to define this query basically into a schema. So what I can do is I can map a query to a query. So this is my query name, so I'm mapping it to a query object of my schema. So this is in place. Now what we have defined the actor into Java class, we have defined the film, but we haven't defined this get all actors implementation anywhere. So this is something that we need to define, so that GraphQL framework can identify it and send back the response. So what we can do is we can basically, since we have created two services, we can create an implementation of it into our service class. So since this is not accepting any parameters, it will be all of actors that we need to return. I'll say this is returning a list of actors to you, and we can fetch it using a repository. So let me auto wire the repository here. Actor repository, and we'll fetch all the actors from a database. Find all. Okay, now since our database is empty and there will be nothing in the database, so what we need to do is we basically need to put some data onto our database. So what I will do is I'll create another service. I'll say data loader service, and let's make it as a Spring Bean. So what we should do is once this bean is getting created, we will call, or once the once this bean is getting created, we'll basically call the post construct method of this Spring will call the post construct method of this bean, and here we'll load all the data. So since we are storing the data into the database, we need a repository. So I'll say actor repository, I'll auto wire it, and I'll save some films as well. So I'll get the film repository as well. and I'll say film repository. Okay, and I'll copy the implementation that I've created earlier. So let me get the implementation basically. Okay, so let me import the things which is not there. Okay, just need to change the name of my repository and everything should be good. Okay, everything is compiling fine. So whenever our service comes up, it will add certain data into our repository. So I'm basically getting few of the Indian actors names, some Bollywood actors, and basically storing those into our database. And I'm basically storing one of their film into our film table as well. Okay, so let's see if once we bring our service up how it behaves. So before doing that, we have created our query called as get all actors, but for GraphQL framework to identify it, basically we need to implement one interface of GraphQL framework so that it will get injected at the GraphQL runtime. So what I will do is I need to, because this is a query, we need to implement an interface called as GraphQL query resolver. So once service comes up, they will find that what are the classes implementing this interface, and whatever the public method specified into those classes, it will be registered as a query, and it will try to map this name with the name that you specified into your schema file. So they should match one to one. So name as well as the data type should match. So let's try to bring up our service first. Um, to test our service, basically we need to um, access one of the UI which has been provided by the graphical Java tools that we added into our POM file. To enable that UI interface, I need to add certain properties into it. So what I can do is I will add 3 new properties. So basically what I'm doing saying is whenever I'm calling any endpoint from my graphical UI, it is mapped to a servlet called as GraphQL, and this name can be anything. You can customize your name as you want, but this will become your something called as a something like a context in terms of REST terminologies. Okay, servlet is enabled. Servlet mapping, which is a name for your servlet, and this is to make a cross origin request. So let me run my class and then we'll see if it is coming up or not. I'll build my project. Okay, just give a couple of minutes for it to build it out, and we should be ready with our first query in GraphQL. Okay, my project has been built, so let me run it. Okay, let's see. Service is coming up. Okay, my service is up and it is up on port 8080 default port. So let's try to access that service. So, and as I told you, there is one UI tool provided by the framework itself, from which we can test our endpoint. So basically I will access it into slash graphical interface. Okay, so this is our graphical interface. So now we'll see here what are the things which have been provided by our schema. So see, our query has been registered properly, our ID actor type has been registered as well. So film as a type is not appearing here because we haven't exposed it as part of any of the query as of yet. So once we expose it, it will start appearing here as well. So let's try to see how we can query those. So since it is a query, I need to create my GraphQL DSL, and it will give you auto populated or the smart completion suggestions as well. So this is my query name, and since it is red because it is saying that get all actors basically give you an actor field or actor type. Now this is the difference between the REST world and the GraphQL world. You cannot just send the entire object out to the client side. So client has to specify out of those 4 or 5 fields which is there as part of actor, which are the fields that you're interested into. So basically here into the curly braces we'll see what are the fields that we want. So these are the fields which is part of your actor type. So I'll say I need actor ID, I need first name, I need last name, I need address, I need suppose film ID. Okay, and if I run it, this should fetch it. If you see, this has been fetched from the database and show it to me. ID has been auto populated for them, and these are the names of your actors which is we specified saved into the database. Now it is associated with film as well. So our first query has been working perfectly fine. So the next query that we'll create is will basically call a actor or try to fetch an actor using the actor ID itself. So let's see how we can do that. Okay, so I'll create one more service into I'll create one more query into the actor service itself. So I'll say, and this should just return one actor to me, get actor by ID, and since this is a public method it will be auto registered into the GraphQL framework. So I'll say repository dot find by ID, and user need to specify their ID itself. So I say user is passing the ID to me and I'll pass it on here. Okay, this will be an optional, so I'll get an actual object. So let's restart the okay, so we need to put it in the schema file as well, otherwise it will not be picked up. Okay, my second query, and this will be just returning an actor and expecting one parameter. So I say ID and it has to be an int. Okay, so from the client side they have to send this parameter to fetch the actor. So let's restart it again and then we'll see how it works. Okay, service is up. Let's try refresh my browser again. Let's see, let's make the same query again. It is still returning the same data. Now we should see one more query, and this is the power of GraphQL. Into the same thing I can call multiple endpoints. You can think it as a different endpoints from a Java world, from the REST world, wherein there you cannot call them in a single query. Here I can combine those and fetch the data. So in the first one I'm getting all the actors. Now I can see that if I want the actor suppose which is associated with actor ID 4, so how we can get those, right? So since this is expecting one parameter, I say ID, its type is int, No, so it has its value is 4, and let's get all those data again. So here I'm hard coding the id value, but we'll see how we can parameterize those as well. uh, so let's see if it works or not. So this is the first response and this is the second response. We have fetched the actor for that id number 4. Now if you want to parameterize this, how we can do it? So let's see how we can do is, I don't want to hard code it here, so I can parameterize this into my query itself. So I say id, its type is integer, and it has to be specified with $sign, and here I say I say id. Now this is getting passed, we need to pass it somewhere, so we'll see from a query params I say id and its value will be 4. Okay, now exactly the same response that we got, we should get it back again. So this is a parameterization of your query. We are getting the same thing. If I change it to 6 and if I remove it now, I just want 6, I should just get one response back. Okay, now the second concept that we want to see is basically if I want to change or rename the response, the property names which have been sent it by the server itself. So I don't like last name or the first name property. I want it to be sent by a different name itself. So what you can do is in the query itself, what you can see, if I don't want to have it as a first name, I say if I want in caps first underscore name, how we can do is you can put it like this. It is called as an alias in GraphQL terminology, and if I run it now, the response should be like this. It's very easy by which the client is basically controlling the response format for your queries. Okay, now after these two basic queries, what we can do is we want to find out the films this actor is working into. So how we can do that? So one of the ways basically you can put join within your table itself. So whenever actor is getting fetched, it will fetch the films as well, but that will create a coupling between your two entities. We don't want that. So the next thing what you can do is basically there is something called as GraphQL type resolver. Whenever actor getting resolved, basically you can ask GraphQL to resolve the films as well if it has been specified into the query. So what we can do is I'll create one more service called as film resolver. Sorry for the caps. Okay, and this has to be a Spring service again, and it has to implement another interface called as GraphQL type or GraphQL. It's called GraphQL resolver, and we need to resolve it whenever actor object getting resolved. So whenever actor is getting resolved, we need to resolve or fetch the films that actor is worked into as well. So let me get the film repository, and this is how there is no direct uh, wiring of the logic in the actor service, but this is completely decoupled. Now I say I want a film as well, so I say get film, and since this has to be resolved whenever actor is getting resolved, it should receive an input parameter with actor. So what we can do is, so actor has a film ID as a property inside it. So this should return a film. It should fetch a film from the database in which that actor has worked on. Now this is fine, but again this has to be specified into a schema file. So what we can do is we can say whenever actor is getting resolved, it can potentially fetch the films as well. So I'll say film and its type is film. Okay, so let's restart it one more time. Okay, service is coming up. Now let's see if we can fetch the films as well as part of actor. Okay, if I run the query again, it is fetching the usual attributes, but let's see if I have a film attribute now. If you see, the new attribute is appearing called as film, and it is giving me an error because it is a complex object. You need to specify from this film object what all parameters you want. So if I say film ID and name I want, if I make a query now, okay, somehow the name is not coming back. Okay, I think the error is because it is a lazy object. We need to put it in the transactional context so that it will be fetched eagerly. So let me do that. Go to film resolver again. I'll put it so that it should be available. So let me restart it one more time. Okay, service is up. Let's see now if it is working or not. Let me run it again. Still failing. Okay, looks like somehow this is not getting initialized properly. So let me try find by ID. Okay, let's refresh the server again. Service is coming up. Let's try it one more time. This time it is working fine. Okay, so as part of actor, we have fetched the films as well, and it is giving the film data which is there as well. Okay, so this is how you can combine the data from two different data sources and send it as part of the same response object back to the client without coupling your logic onto the server side. So this is called as query. Now we'll move on to the next part called as mutation. So as the name suggests, mutation is nothing but you are updating certain data into your um, you're updating certain data onto the server side. So let's see what we can do. We'll create one mutation object in which suppose we update the address of an actor. Okay, so let's see how we can do that. So I'll go back to my tutorial and I'll create in my actor service as a query resolver. We'll implement one more interface called as mutation resolver as well. Okay, so with mutation resolver, I'll say I'll update the address, update address, and how I can do that is I'll make it transactional first. Basically, I'll receive a ID of an actor, and for that ID we'll receive a new address as well, and we'll update that. So what we can do is we can first fetch the actor from a database, actor repository. I think it's just repository dot find by ID. Okay, let's update set address. This will be a new address, and then we will save it in the repository itself. Dot save actor, and we'll return the new actor object back. Now since this is a mutation, we need to create a mutation into the schema file as well. So first we created a query, now we created a mutation. This is my mutation name. This is returning an actor. This expects two parameters and address is string, and register this mutation into my schema as well. So mutation is registered. Okay, looks fine. So let's try this one. I'm restarting my server. Server is coming up. Okay, server is coming up now. And let's see. Okay, server is up. Let's try it now. I'll refresh my browser. First see, now the address for this actor is Mumbai, India, and we want to modify it. So, and its ID is 6. So let's see how we can do that. So I don't need a query, I need a mutation now, and I update address. First need an ID is 6. Address, if I say his address is Delhi, India, and I need an actor ID back, first name back, last name back, and the new address. So let's see. Right, this is written back properly. If I make a query again, I should get a Delhi, India back. So let's see, I make a query, get actor by actor ID, ID is 6, actor ID, and say first name, last name, address. Okay, it is coming perfectly fine. Okay, so this is how you can do a mutation. Now if you noticed, if I go back to the mutation query that I have written, okay, so here I am sending objects or the properties that we need to our mutation endpoint one by one. But if it is a large number of properties, how we can send that? We can send something called as an object or an input object back to the server itself, and that object can be defined in the server side so that both client and the server are in sync. Server can specify to the client what is object it is expecting while updating or running any particular mutation. So what I can do is I can basically create an input object. If I say address input, okay, and this should implement again the GraphQL input type. This should implement a method called as get name. And here if you say address update, it should have two parameters, actor ID and the address. Okay, let's get the getter setter. Now let's see how we can use this to get input from the client side and how we can use it on the mutation itself. So if I go back to my service, here I'm getting the individual properties. So what I can do is I'll create one more endpoint and I say update address by input object, and I don't need this one now. I'll just get an input object itself. Address input. Okay, Now I say input.getActorID, input.getAddress. Okay, now let's register this into the schema file. It's another mutation, and this time we need to specify the input object as well into as a type. So I say type address input, need two parameters. I say actor ID int and address as string. Okay, type is input. Here we need input of type address input. Okay, let's restart the server again. Let's see how it works now. Okay, server is coming up. Let's try the input object now. Okay, we don't need an update address now. We say update address by input object, and it need a address input. I say input okay, need last name and I need address. Now we need to send this address input as an object to my backend, so I need to specify it first. So this is the name of my object as a JSON key. Need an actor ID, suppose 6. Address, if this time I say Bangalore, India. Okay, comma. Okay, there is a typo, I think. So let me run this. Something wrong. Okay, let me see what's an issue now. There was a typo for address. We need to resolve it and restart it again. So let me restart it. I've changed the address. This should work this time. Okay, service is up. Now let's see how we can access those. And this is now address. Okay, run it, worked perfectly fine. So this is how you can do a mutation as of it. Now before we go to subscription, there are a couple of points that I wanted to tell you. So let me go to query again, our first query. Let's say 6 actor ID, first name, last name, and film. So for film, I get name, film ID. Now, what if this film response that I'm getting as part of my query, I want to make it conditional? So if I give certain attribute, if that condition is true, then only I want to receive that as a response, otherwise I don't. So there is a way by which you can do it in a query, something called as directive. So here I say include if, and because this is a condition I need to give a boolean object, so I say with film, right? If this with film as a parameter which has been coming to my query, if it is there and if it is true, then only I want to see a film object in the response. So I say dollar with film. This has to be a boolean, a mandatory one. Now notice we are putting this object, but we are not making any changes into our server side code. Okay, so this is again benefit of working onto the GraphQL, that there are certain advantages on the client side that they can control the response which has been coming in. Okay, so now let's see. I first say true, so I should get a response, film response back, so I'm getting it. Now if I say false, this should not be coming back. You see, now there is no film object into the response. So this is again another point that I wanted to cover, which is called as directive. Now there is another building blocks for GraphQL, something called as fragment. Fragment is nothing but if there are certain attributes which are getting repeated multiple times into a query, you can abstract it out and keep it somewhere which client can use it. So if I say I want to define a fragment, I can client side and I will see how we can define it. If I say fragment actor details on actor, say actor name, first name and last name. So this is a section or a fragment that we have defined. So what we can do is whenever we are want to get these three fields as one go, we can basically replace it using a fragment itself. So how we can specify fragment with these three dots, and then I can say actor details. Okay, now let's see if it works. It's working fine. True, should get both the details. Okay, so this is a fragment. Now only the last section which has been remaining for us to cover is something called a subscription. Subscription is nothing but, as I told you earlier, it is some kind of a push notifications that server can send it to the client. So what we can do is we can go back to our server, and I'll go to my POM file. I can implement a subscription using the new Spring Reactor project that we are having. So I'll get a reactor core dependency into my class path, and the version I'll put the latest one. So let me refresh it. So what I can do is I want to create a subscription on actor update. So whenever actor is getting updated, I want to send that as a push notification to our client. So for that, what I can do is I want to maintain a map of all the clients which are interested into this subscription. So whenever they subscribe to it, I will basically maintain their reference into our server side. So I'll get one concurrent hash map where I'll be maintaining a map of actor ID in which they are interested into, and we'll create something called as flux sync. So this is a, I'll not go into details of what flux is all about. You can go into Spring tutorials. So there is a way by which you can return a stream of data back to the client itself. So we'll create a flux sync of actors. So what we can do is we'll basically on actor update, we want to receive a notification. So this will give you the actor ID. So this will give you the actor ID. and this actor ID will basically create a map. So let me change it. And this will return a publisher of actor. Okay, so what we're doing is whenever actor is getting updated, we want to return a push actor object as a push notification back onto the server side. So these are two of our mutations. So here is the actor address is getting updated. So what we can do is I'll say I'll get for that particular actor ID. So I'll say my map name is subscribers. Subscribers don't get actor ID. If it is not null, then basically what I would do is this is after saving. I'll do subscriber.get actor ID, and I'll basically just notify the client about it with the new actor object. Okay, what's the problem? Oh, I think we are missing a bracket. Should be good now. Okay, can put it in our other mutation as well. And here I don't need an input object. I already have an ID available at this end. Okay, so let's refresh. Let's build my server again. Okay, my server is up. I'll go back. So this time what I can do is I'll open two different prompts. So in one will be subscribing to the events and another one will be updating the object. So here what I will do is I'll subscribe. One thing we have missed, I think we need to implement the GraphQL subscriber resolver. So that's one thing. And another thing that we need to do is we need to add this into the schema file as well. So I'll go to the schema file. So this will be of type subscription on actor update. So this needs an actor ID of type int, and this will return a actor back. Okay, register the subscription as well. Okay, now we are set. Let's for the last time. Okay, server is up. I'll go back. So I'll have two prompts open. In the one will basically creating a subscription of, in the one prompt will be subscribing to the events, in another prompt will be changing the address of an actor. So let's see, this is my subscription, and I'll, okay, something wrong. Okay, I'm getting a subscription on actor update, actor ID, I'll hard code it for now, 6. And whenever I get a push notification, I want to see the actor name, first name, last name, and address. Okay, and here we'll be updating the address of a user actor. So from Bangalore this time, let's say Hyderabad. Okay, so let me first subscribe to the event. So now here it's subscribing. This time I'll mutate it and it receives the update back as well. So if I change it again, this time I say Noida, I get another object, update back. Okay, so this is how you can basically implement the subscription as well. So this is pretty much it. So we have covered all the building blocks of the GraphQL, how to implement it in Java. We covered the types, what is types, what is query, what is mutation, what is subscription, what is fragment, how to implement the fragment, what is directive to basically control the response conditionally. So we have covered most of the things. So and again, the way I mentioned, this is basically a schema first approach, which means that we first define the schema and then we basically coded around it. So I've created another tutorial basically which is called as code first approach, wherein we'll not be handwriting our schema but it will generate it using the code itself. So again, if you have liked the content that I have presented, please do subscribe to my channel and like the content, and press the notification bell icon so that whenever I put the new video you will get update around it. Again, thanks for tuning in. Thank you so much.